This is a third topic for Thermochemistry chapter 2.3 Hess law. We are going to state what is Hess law and have to apply Hess law to calculate enthalpy change using the algebraic method and energy cycle method. So first of all, right, we must know Hess law state that when reactants are converted to product, the change in enthalpy is the same, whether the reaction takes place in one step or in the series of steps. The enthalpy change depends only on the initial and final state of the reactant and product, but is independent of the path taken. Okay, a very important concept over here is about the vector concept. I think this vector is related with mathematics. You learn, right? Okay, for example, A to B, just a one-step reaction. And then from here, A, C, B. So this is two-step reaction. But the final destination is the same, which is B. So meaning that enthalpy 1 actually is equal to enthalpy 2 plus enthalpy 3. So we are going to apply this concept for Hess law, for the energy cycle method, and so on. So there are two methods, algebraic method and energy cycle method. The final answer that you get from these two methods is the same. First, we try to apply algebraic method to solve the Hess's law question. There are three thermochemical equation is given, and then the question asks to calculate the enthalpy formation of ethane C2H6, meaning that we need to know how C2H6 is formed from its element. Okay, based on here, I know there are 2 carbon and then 3 hydrogen. 2 more of carbon plus 3 more of hydrogen and then form the C2H6. Okay, next, how to solve the question by using algebraic method? First, list all the thermochemical equation involved. This one given by the question. Step 2, write the enthalpy formation of the reaction of C2H6. You have to write the targeted equation. So now step 3, right? Before we proceed with step 3, we just have a look. Okay, how to use these 3 thermochemical equation to get the enthalpy of formation for C2H6. First, we check. Okay, C2H6 for the targeted equation is at the product side, but given equation is in the reactant. That's why I need to reverse this equation. Okay, then there are 2 mole of carbon, but over here only 1 mole. That's why the whole equation need to times 2. And then there are 3 mole of hydrogen. That's why the whole equation need to times 3. So while we're doing this, right, the enthalpy also need to times 2, times 3, and then reverse. So negative sign will change to positive sign. Let's check. Step 3, is it the same? Yes, step 3, add the given reaction so that the result is the desired reaction. Yes, times 2. When times 2, the whole equation times 2, enthalpy times 2. Phase insist, the solid, gas insist. Okay, times 3, and then the phase insist. So the enthalpy times 3, and then reverse the whole equation. Okay, and then please write down like this. So the enthalpy of the reaction equal to negative 84 kilojoules. So this is the final equation. This is targeted equation. I will make it as double line like mathematics. So first formula, very good. Enthalpy of formation equal to enthalpy of H1 plus enthalpy of H2 and plus enthalpy of H3. One part is missing, substitution. But right, you have to write down this over here. So have to write down one more time again. So this is the final answer. Okay, clear? Next example, okay, calculate the enthalpy change for the reaction between carbon and hydrogen to form ethane. So ethane is given. Okay, here this is product. Again, I have to reverse. Okay, then 2 mole of carbon, but here only 1 mole. And then so I need to times 2. And then 2 mole of hydrogen, so I need to times 2. Okay, let's check. Is it? You need to enthalpy also need to times 2 times 2. And then this one reverse, so become positive 2490. Yes, times 2 times 2 positive. Yes, very good. So sum up, right? Okay, class. Okay, this is your lecture notes. Please do some correction. Please mention this one is enthalpy H1, enthalpy H2, enthalpy H3, and then write down enthalpy H4. So which is equal to positive 56 kilojoule. Okay, please do it in a complete way. And then over here, yes, very good. Substitution, final answer. But one part is missing. So one part is missing because they didn't write down the relationship. Okay, means it's something like formula. So must write the enthalpy of reaction equal to enthalpy 1 plus enthalpy 2 plus enthalpy 3. Please formula. Okay, then substitution, final answer with the sign positive or negative and kilojoule per mole. So over here is positive. Okay, next example. Okay, given there are three thermochemical equations, and then the question asks, using algebraic method, calculate the enthalpy change for the following reaction, meaning that this one is the targeted equation. Okay, before we check the answer, right, let's try. So this targeted equation over here, this one is reactant, and then over here is product, meaning that this equation need to reverse. And then 6 fluorine. Okay, because there are 3 fluorine over here, okay, we hold first, we proceed with this one, 2CF4. So the over here is 1. That's why this whole equation need to times 2. So while this one times 2, this one equal to 4. Okay, and then 4HF. 4HF. Okay, here 4HF, meaning that this one need to times 2 as well. Okay, yes, settle. If this one times 2 here equal to 2, sum up equal to 6. Okay, meaning that, okay, the first equation times 2. Yes, second equation times 2. Yes, the third equation reverse, positive become negative. Okay, make sure whole equation need to times 2. Phase insist, phase insist. Okay, this one whole equation times 2, enthalpy times 2, and then this one say this whole equation reverse. Initially, this one is product, now become reactant. So now we try to circle the component or the substance or the species that we want. I want this one. Okay, so 4 of 6, and then here 2, here 4HF. So I already highlight with yellow color for the reactant and product that needed. Okay, and then make sure that the rest can be cancelled off. 2 hydrogen cancel off, 2 hydrogen cancel off, 2 carbon cancel off, 2 carbon cancel off. Yes, so this one is the final equation. And then the enthalpy for the reaction, right, you just sum up. So the final answer is enthalpy of reaction equal to negative 2558 kilojoule. Okay, over here there's enthalpy for change for the following action. Okay, and okay, write down the formula. Enthalpy of reaction equal to enthalpy H1 plus enthalpy H2 plus enthalpy H3. And then substitution is this one. Okay, this is the substitution, and then this one is the final answer. Okay, have to rewrite again. Please remember. Okay, next we are going to solve the question by same question but using different method. Just now we use the algebraic method, okay, to calculate the enthalpy for the reaction. 2 carbon react with 3 hydrogen and then produce 18. Now we transform this algebraic method to energy cycle method as usual. So this one is the equation for the enthalpy of formation of ethane C2H6. Now you try to form the energy cycle. So based on this equation, so this is the first equation. So this one is the first equation. Okay, two carbon react with 2 mole of oxygen and then produce 2 CO2. And here 2 CO2, okay, react with 3 water and then form C2H6. Over here there is 7/2 oxygen. Okay, meaning that this is reverse. Notice that reverse, the whole equation reverse. Here is the product. Okay, product. And then over here is the reactant. Okay, and then here, this one is the second equation. This one is the second equation going down. And then just now this one is the third equation. The second equation is 3 hydrogen react with 3/2 oxygen and then produce 3 water. So this is the second equation. Okay, that's why the first equation times 2, because from 1 mole change to 2 mole times 2, and then this one from 1 mole change to 3 mole, that's why I need to times 3, and then this one reverse, that's why negative become positive. So this energy cycle is used to calculate the unknown value for the enthalpy of formation. The concept is the same. Now you have to write down the formula. Enthalpy of formation equal to 2 enthalpy 1 plus 3 times enthalpy 2 and then plus enthalpy 3. Substitution, and then the final answer 84 kilojoule per mole. Meaning that if you want to solve the question with Hess law, we can apply algebraic method or energy cycle method. If you ask madam, right, madam prefer algebraic method. Okay, because energy cycle, there are certain part, right, is not involved, not exactly involved like equation 1. You look at sorry, like equation, this targeted equation, you check with equation 1, the oxygen, and then the equation 2, and then the oxygen is right at the middle of the reaction. Okay, yeah? So you have to be smart. Okay, next. Again, this is a second example for calculate the enthalpy of formation by using energy cycle method. So this is the targeted equation. Sulfur react with oxygen to form sulfur trioxide. So the targeted equation you put on the top, you write on the top, and then so this is the first equation. So this one is the first equation. This is the enthalpy 1. Sulfur react with oxygen produce sulfur dioxide. Then this one is enthalpy 2. So this one is enthalpy 2. Okay. Enthalpy 2, sulfur dioxide react with half mole of oxygen produce sulfur trioxide. Okay, so based on vector concept is first equation plus second equation equal to enthalpy of formation. So enthalpy of formation, okay, here something missing, you have to state the formula first. Over here is enthalpy of formation. If based on the vector is equal to enthalpy 1. Okay, so this is the enthalpy 1 plus enthalpy 2 plus enthalpy 2. So it's negative 287 plus negative 92. That's why you get the final answer is negative 379 kilojoule per mole because it's referred to this one mole. Okay, clear? We try one more question. Try to solve the Hess law problem by using algebraic and energy cycle method. So hydrazine N2H4 is used as a rocket fuel since its reaction with oxygen is extremely exothermic. So this is the equation 1. Thermochemical equation 1. Calculate the enthalpy of reaction with liquid water. The question 1, the enthalpy reaction with liquid water is produced instead of steam. So you check the equation, which one is what liquid water is produced? The answer is this one. So meaning that equation 2 is the targeted equation. Okay, the question we're not sure which one is the targeted equation. You have to read the question carefully and analyze it. Meaning that, okay, this one is the targeted equation. So that's why we put on the top. So N2H4, liquid oxygen, react, produce nitrogen and water. So this is the enthalpy of the reaction that we need to find out. So we're not sure. Okay. Okay, next. Now we have to play around with the equation 1 and equation 3. So for here, N2H4, right? Okay, react with oxygen. Okay. Oxygen gas produce nitrogen gas plus 2H2O gas. So the enthalpy for the thermochemical equation 1 required as enthalpy 1 with negative 534 kilojoule. Next, equation 3, okay, is emphasized on water. Oh, sorry, not water. Here is steam. Okay, steam. Initially, here only 1 mole of steam. Now, here is 2. That's why the whole enthalpy, you need 2 times 2. At the same time, now this H2O steam is the reactant. That's why you have to reverse the equation. And then the positive will change to negative sign. So negative 40.7 kilojoule times 2. So this is the thermochemical equation for the reaction 3. Okay, now the enthalpy of reaction equal to 1 plus 3. So the enthalpy 1 plus enthalpy 2. Okay, check. Then is equal to negative 534 kilojoule minus 81.4 kilojoule. That's why it's negative 614 kilojoule. Okay, over here is not per mole because you check water is 2 mole. That's why the unit just kilojoule. Okay, you have to check. The question is referred to reactant or product. And then you check the number of mole of the reactant or product. If 1 mole, yes, kilojoule per mole. If not 1 mole, just kilojoule. Clear? Okay, this same question, but we solve it by algebraic method. So this is the target equation. So list down all the equation involved. As I said before, I will circle the reactant or product that needed. So I need that I want. So I want N2H4 oxygen, and then nitrogen as the product, and water liquids as the product. So meaning that this equation I need to reverse N times 2 as well, because initially only 1 mole. So the first equation remain the same. The second equation reverse times 2. So you have to rewrite again. For algebraic method, you must rewrite again. For step 3, you rewrite again. And then cancel off the unwanted species. Okay, and then sum up. So enthalpy 1 with this enthalpy values, enthalpy 2 with this enthalpy value, and then the whole enthalpy reaction you just sum up, equal to negative 615.4 kilojoule. Don't forget, must write the formula, substitution, final answer with unit. This is the complete way to solve the Hess law question by using algebraic method. Okay, last, there are 6 questions in your tutorial books that related with Hess law. So these are the final answer. You try to solve it by yourself during this weekend. Okay, for the first one, let's check out. Have a quick view. Enthalpy of combustion and carbon monoxide given below, and then calculate the heat change for the following reaction. Okay, carbon, oxygen, and then 2CO. Alert, 2CO, meaning that here CO is at the reactant, now product, meaning that the whole equation need to reverse N times 2 and then sum up. Okay, and then okay, I give so one question solved already, because this is exactly same as my example. Okay, so total only 1, 2, 3, 4, 5, 6. You need to solve 5 questions only. And then I think this one also quite familiar, right? So now you need to solve 4 questions only. This one, is it the same? Okay, not the same, but quite familiar. I think you should know already. Okay, if the question didn't emphasize algebraic method or energy cycle method, up to you. Okay, for information, question 16 is a tough question. If you solve it by formula, yes, very simple. But if you solve it by algebraic method, right, you have to write out all the element, meaning that, okay, 1, 2, 3, this 3 is the enthalpy of formation of CaSO4 dot half water. You have to write down this enthalpy of formation equation by yourself. You have to write down these 3 thermochemical equations by yourself, meaning that I give you the example, H2O. Okay, how to form the H2O? H2 gas plus half mole of oxygen and then produce H2O. Get it? Okay, the H2O is water, means it's liquid. Phase insists the balance number of mole must be correct. And then must write out the enthalpy as well. Here, so I give you some hints again. For this one, calcium SO4 means that calcium plus sulfur plus oxygen molecule and then plus hydrogen molecule. So make sure you balance the whole equation and then get this one. After you form these 3 thermochemical equation, then this is the targeted equation. Okay, so you try to play around the 3 thermochemical equation that you form. If these 3 thermochemical equation something wrong, meaning that you are unable to get the targeted equation as well. Be careful. So question 16, you have to apply 2 methods. One is formula. Another one is you have to write down the thermochemical equation for the whole thing. Then list down enthalpy 1, enthalpy 2, enthalpy 3, and then you play around and get the enthalpy of reaction. Okay, how about this one? This one, okay, C2H2, and then given 1, 2, 3, 4, 5 chemical equation. Okay, calcium carbide. Okay, this is the calcium carbide. So meaning that you need to form the targeted equation by yourself, then only play around with these 5 thermochemical equation to get the targeted equation. Get it? Okay, try it. Be hardworking, be smart. Bye.